An object brighter than a comet, faster than an asteroid, just entered our solar system. Scientists didn't expect it. It's called 3I Atlas, and it's only the third interstellar visitor ever seen. But here's the twist. Some experts believe it might not be natural. What if this isn't just a rock from another star, but a message? In the vast, cold silence of space, something unexpected has arrived. First detected in the final days of June 2025, a strange object began moving through our solar system, fast, luminous, and entirely out of place. At first, astronomers thought it might be just another comet or asteroid, but the more they studied it, the clearer it became. This object isn't from here. It came from the space between stars, what scientists call interstellar space, and now it's moving directly through our cosmic neighborhood. They've named it 3I Atlas, marking it as only the third known object from outside our solar system to ever be observed up close. The first was Oumuamua, a mysterious cigar-shaped rock that baffled scientists in 2017. The second was Borisov, a comet-like traveler seen in 2019. But 3I Atlas, it's different, bigger, brighter, and possibly far more important. Its unusual speed, unexpected brightness, and uncertain nature have scientists questioning everything, including whether it might even be artificial. In this video, we'll dive deep into what we know about 3I Atlas, how it was discovered, what it's made of, where it's headed, and we'll explore one extraordinary possibility. What if this isn't just another cosmic rock? What if this object, crossing millions of miles of empty space, is a message from somewhere else? It began quietly. No sirens, no live broadcast, no bold announcement from NASA. Just a line of unusual data picked up by an automated telescope on routine night between June 25th and June 29th, 2025. The ATLAS system, short for Asteroid Terrestrial Impact Last Alert System, detected an object moving across the night sky. ATLAS wasn't looking for interstellar mysteries. It was doing its job, scanning for near-Earth asteroids that could one day pose a threat to our planet. The system runs 4 telescopes in Hawaii and South Africa, automatically capturing snapshots of the sky, analyzing brightness, speed, and motion every single night. But this object didn't behave like the rest. First, its brightness stood out, then its speed, and finally, and most alarmingly, its trajectory. It wasn't looping around the sun like our planets. It wasn't drifting in from the Kuiper Belt or the Oort cloud like typical comets. It was coming in fast, from interstellar space. That alone would have been enough to raise eyebrows. But the story was only just beginning. Shortly after the initial detection, the object's data was sent to NASA's Center for Near-Earth Object Studies, CNEOS. Teams there quickly ruled out false positives. No camera glitches, no lens flare, no satellite reflection. This thing was real. A mysterious object, unknown and fast-moving, had just entered our solar system, but confirmation wasn't enough. Astronomers needed a clearer picture, more data, more time, more sightings. And then, something remarkable happened. An amateur astronomer named Sam Dean stepped into the story. With a passion for space and a keen eye for anomalies, Dean dove into the archived data from ATLAS, images captured before the object had even been officially flagged. And he found it. Hidden in plain sight, the object had been photographed several nights earlier. It was there all along, just waiting to be noticed. This breakthrough allowed scientists to rewind the clock, recalculating the object's origin and trajectory with far greater accuracy. What they found was conclusive. This object had not come from the outer edges of our solar system. It had entered from beyond, from the deep cold between the stars. In other words, it was interstellar. Telescopes around the globe quickly joined the chase. Within just 2 days, over 100 separate observatories had submitted sightings to the Minor Planet Center, the international clearinghouse for tracking solar system bodies. And on July 2, 2025, the object was officially named 3I Atlas. 3I, because it is the third known interstellar object ever observed from Earth. Atlas, honoring the survey system that discovered it. To grasp how rare this is, consider this. Until 2017, no confirmed interstellar object had ever been seen in our skies. Then came one, Oumuamua, the bizarre, elongated mystery that sparked debates about alien technology. In 2019, we observed 2I Borisov, a more comet-like body with familiar traits. And now, just a few years later, a third. But unlike the others, 3I Atlas is already exhibiting behavior and characteristics that don't entirely fit the pattern. The question now is, what exactly is this object? Is it a comet, an asteroid, a chunk of interstellar debris flung out of a dying star system? Or is it something entirely different? The moment 3I Atlas was confirmed to be interstellar, one question echoed across the scientific world. What is it? And, just as importantly, what isn't it? Could it be a comet, shedding ice and dust as it nears the sun? Could it be a rogue asteroid, ejected from a distant planetary system millions of years ago? Or could it be something we've never seen before? A completely new category of interstellar object? The answer may lie in what it's not doing. So far, 3I Atlas shows no clear signs of outgassing, no visible tail, no jets of material, no cometary coma. But at the same time, it's unusually bright. Brightness without outgassing is highly unusual for an object entering the inner solar system. And that's when Dr. Avi Loeb enters the picture. A theoretical physicist and former chair of Harvard's astronomy department, Loeb has never shied away from controversial ideas. He famously suggested in 2018 that Oumuamua's strange shape and unexplained acceleration could indicate artificial origin, perhaps even a solar sail from another civilization. Now, he's urging the scientific community to pay very close attention to 3I Atlas. In a recent statement, Loeb proposed using the James Webb Space Telescope to observe the object during its closest approach to the Sun. His goal? To look for signs of non-gravitational acceleration, that is, movement that can't be explained by gravity alone. Think about it. If something moves in space without a tail, without propulsion, but still speeds up or changes direction, that defies everything we expect from natural objects. With Oumuamua, scientists were puzzled by its subtle acceleration away from the Sun, even though it had no visible emissions or gas jets. Some said it might be due to invisible hydrogen ice or dust escaping the surface. Others weren't convinced. Loeb believes that if 3I Atlas shows similar unexplained motion, it could support the hypothesis that these interstellar visitors are not just random debris, but rather that they may have been designed. Now, let's be clear. This doesn't mean that 3I Atlas is a spacecraft, but the fact that top-level scientists are even considering that possibility publicly tells us just how strange this object already is. And it's not just the motion or the brightness. According to initial observations, the surface of 31 Atlas reflects more sunlight than expected for its estimated size. That could mean the object is much larger than initially thought, possibly as wide as 12 to 20 kilometers, or that it has a highly reflective surface, something smoother or shinier than typical space rock. Could it be metal, crystalline, artificially polished? No one knows yet, but the scientific community is watching closely, and more importantly, they're racing against time. 3I Atlas is moving fast, and once it slingshots around the sun, it may vanish into deep space forever, just like Oumuamua did. That leaves a narrow window, just a few months, to gather as much data as possible. Data that could answer the big questions, or open new ones we never imagined. To understand how extraordinary 3I Atlas really is, we need to examine what it is, how it moves, and what it might be made of. Let's start with its speed, because it's unlike almost anything we've seen before. 3I Atlas is currently traveling at a staggering 152,000 miles per hour. That's over 245,000 kilometers per hour. To put that in perspective, if you were somehow able to drive a car at that speed, you could circle the Earth in under 10 minutes. And more importantly, that velocity is far too fast for any object gravitationally bound to our sun, meaning it isn't part of our solar system. It's just passing through. But the object's path is just as fascinating as its speed. Current models show that 3I Atlas entered the solar system from a highly hyperbolic orbit, a curved path that only objects from interstellar space exhibit. Unlike comets or asteroids that circle the sun in predictable ellipses, 3I Atlas is moving on a one-time flyby trajectory. It came in, it will loop near the sun, and then it will be gone forever. Right now, it's about 3.8 astronomical units from the sun. That's roughly 4 times farther than Earth's distance. According to predictions, its first planetary flyby will occur on October 3rd, 2025, when it passes relatively close to Mars. Then on October 23rd, it will reach perihelion, its closest point to the sun, at about 2 astronomical units, or twice Earth's distance from the sun. During this phase, scientists hope to get better measurements of the object's surface, shape, and behavior, but Earth won't get a front-row seat. In fact, during the closest approach to the sun, Earth will be on the opposite side, far out of observational range. Its closest approach to Earth will actually happen in December 2025, but even then, it will remain a safe distance away. No threat, no impact risk, just a silent traveler moving through our solar system on its way back into the void. And yet, it's what we can see that's raising even more eyebrows. One of the most puzzling characteristics of 3I Atlas is its brightness. It reflects more sunlight than scientists initially expected. Normally, the brightness of an object tells us something about its size. The more light it reflects, the bigger it probably is. But if the surface is unusually reflective, that changes the math. Harvard's Loeb made a bold calculation. If the surface of 3I Atlas were dark and rocky, like a typical asteroid, it would need to be at least 12 to 20 kilometers wide to reflect this much light. That's massive. Far larger than Oumuamua, which was estimated to be only a few hundred meters long. But if 3I Atlas has a metallic or icy surface, it could be much smaller, and yet still just as bright. So, which is it? A giant dark rock, or a smaller object with a highly reflective shell? And here's where it gets even more curious. So far, no visible coma, no tail, and no outgassing have been detected, all things we expect from a comet passing near the sun. This raises a key question. If it's not acting like a comet, and it's not acting like a typical asteroid, then what is it acting like? Could it be covered in metal, a natural crystalline surface, or something else entirely? Some researchers speculate that its surface might be smooth or even artificially polished, giving it an abnormally high albedo or reflectivity. If that's the case, what could have made it so smooth? Time and collisions tend to scar and roughen objects in space. Something this polished would either have to be young, recently formed, or manipulated. But again, that's just one hypothesis. For now, all we know for certain is this: 3I Atlas is moving faster than almost anything we've tracked. It's brighter than we expected, and its behavior so far does not match our expectations for a natural object. But as it moves deeper into the inner solar system, scientists are racing to gather data, because once it passes the sun, it may be gone forever. And the chance to study an interstellar traveler up close in real time may not come again for years or decades. 3I Atlas isn't the first interstellar visitor to surprise scientists, but it may be the most mysterious yet, because the more we learn about this object, the more it seems to echo the bizarre traits of its predecessors, while adding entirely new layers of intrigue. To understand why this is such a monumental discovery, let's rewind time and revisit the two objects that came before it. In October of 2017, astronomers at the Pan-STARRS Observatory in Hawaii spotted something truly strange. A long, narrow object was speeding through our solar system, but not on an elliptical orbit like a planet or comet. Instead, its path was hyperbolic, an arc that could only belong to something that came from outside the gravitational influence of the sun. It wasn't bound to us. It had entered from interstellar space, and it was already on its way out. They called it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. And it was given the designation 1I, the first recognized interstellar object ever recorded by humanity. But Oumuamua wasn't just unusual because of where it came from. It was unlike anything we'd ever seen. Estimates of its shape suggested it was either long and cigar-like or flat and disc-shaped, with extreme proportions never before observed in nature. It rotated erratically, reflecting sunlight in unpredictable patterns. But the biggest mystery, as it left the inner solar system, it sped up. Just a little, but enough to get scientists talking. There was no visible gas or tail, no evidence of outgassing, as we'd expect from a comet. Yet the object was accelerating, a behavior inconsistent with known physics, unless some kind of force was at play. This led some scientists to propose exotic explanations, from outgassing hydrogen ice to pressure from sunlight on a thin, flat surface. But one voice made headlines around the world. Avi Loeb, then chair of Harvard's astronomy department, suggested something no one else dared to say aloud. What if Oumuamua was not a natural object? What if it was a solar sail, a type of alien spacecraft designed to ride the radiation of stars like wind in space? His proposal was controversial. Many dismissed it outright. But some listened, because when nature presents us with a puzzle that doesn't fit, we must at least be willing to ask difficult questions. Sadly, before we could gather more data, Oumuamua was gone, vanishing into deep space and taking its secrets with it. Then, just 2 years later, in August 2019, astronomers detected a second interstellar object. This time, it was unmistakably a comet. Named 2I Borisov, it came with all the hallmarks of a classic icy traveler: a bright coma, a long tail, and clear outgassing as it neared the sun. It looked and behaved like something we'd seen before, except for one thing: its origin. Just like Oumuamua, Borisov had entered the solar system from beyond. And it wasn't just similar to known comets, it was more pristine. Borisov's composition revealed extremely pure ices and a high level of carbon monoxide, suggesting it had formed in a colder, more remote region than any comet in our own solar system. It may have come from the outer edges of a young planetary system still in formation, light years away. So now we had two data points: one object bizarre and inexplicable, another comet-like and expected. And now comes the third. 3I Atlas, an object that seems to blur the lines between the first two. Like Oumuamua, it's moving fast, reflects more light than expected, and, so far, shows no signs of a tail. Like Borisov, it appears large and is being tracked extensively with time to prepare. But it also brings new mysteries: its potential size, its unexplained brightness, and its still unclear composition. All of which leaves scientists asking, is this the new normal? Are we finally detecting a class of interstellar objects that have always passed through our solar system, unnoticed? Or is something changing? Have these objects only just begun to arrive, perhaps launched or ejected in some kind of pattern? And if so, who or what might be sending them? With 3I Atlas now confirmed as the third known interstellar object ever observed, one thing is becoming clear: these visitors are no longer a once-in-a-lifetime anomaly. In just under a decade, we've gone from 0 interstellar detections to 3. That raises a powerful question: why now? For centuries, we scanned the skies without ever seeing a single object from beyond our star system. So why are we seeing them so frequently today? One theory is simple: we just couldn't see them before. Our detection tools were less sensitive, our sky surveys less frequent. It's possible that interstellar objects have been quietly passing through for millions of years, unnoticed, unmeasured, unremembered. But not everyone is convinced it's that simple. A growing number of astronomers are starting to wonder, what if something has changed? What if the frequency of these objects is increasing, not because of our instruments, but because of the universe itself? Some speculate that a distant astronomical event, like the collapse of a planetary system or a stellar explosion, may have flung a cluster of debris across space. Objects like 3I Atlas could be fragments of a shattered world, slowly spreading through the galaxy over time. Others propose that these objects may be part of a natural migration, rare cosmic drifters that occasionally slip through interstellar space, crossing paths with systems like ours. But then, there are the radical ideas, the ones that make some scientists uncomfortable, and others extremely curious. Ideas that challenge our deepest assumptions. What if objects like 3I Atlas are not entirely natural? What if they're not debris, but devices, probes, sent by other civilizations, not to communicate directly, but to observe? Think about it. If a civilization existed elsewhere in the galaxy, separated from us by thousands of light years, how would they explore? Sending ships with living beings would be slow, dangerous, and inefficient. But sending small, durable, autonomous probes, built to drift silently for millions of years until they stumble upon systems like ours? That's not just science fiction. It's plausible strategy. Some researchers have gone as far as suggesting that we may be seeing a form of technological litter, fragments of ancient devices that outlasted the species that built them. In this view, 3-eye atlas could be a remnant, not of a planet, but of a mind. The reflective surface, the lack of a tail, the unexplained brightness. Clues that point not to randomness, but to design. Of course, these ideas are speculative, but speculation is the beginning of science, not the end. Every great discovery in history began with a question that sounded impossible. What if the Earth moves? What if invisible forces shape the stars? What if life exists somewhere else? Now, in 2025, we must ask another. Are we truly alone in the cosmos? Or have we just received another silent visitor drifting past us with secrets we've yet to unlock? The clock is ticking. 3-eye atlas is moving rapidly through the solar system. In just a few months, it will swing past the sun and then vanish into deep space. We may never see it again. That makes what we do right now more important than ever. Fortunately, we live in a golden age of astronomical observation, and the tools we have today, and the ones about to come online, are more powerful than anything humans have ever built. Our first line of defense and discovery is already at work: the Atlas system. This network of robotic telescopes in Hawaii and South Africa is scanning the sky every night for fast-moving or unusual objects. It was Atlas that first spotted this interstellar intruder, but now that we know 3-eye atlas is here, a much bigger stage opens up. Observatories around the world, from Chile to Spain to the Canary Islands, are adjusting their instruments to follow its path. But the real game changer may come from space. The James Webb Space Telescope, launched in 2021, has already transformed our understanding of the early universe, exoplanet atmospheres, and distant galaxies. Now scientists are proposing that Webb be pointed at 31 Atlas. Using its advanced infrared instruments, JWST could detect the composition of its surface, measure its temperature, and even look for signs of outgassing too faint for optical telescopes. If 3-eye atlas is truly something unusual, whether because of its reflectivity, its shape, or its motion, Webb could help answer questions that ground-based telescopes simply can't. But JWST isn't alone. In the near future, another revolutionary tool will begin scanning the heavens. The Rubin Observatory, currently under construction in Chile, is expected to go online in the next couple of years. Once operational, it will conduct the Legacy Survey of Space and Time, LSST, the most ambitious sky mapping project ever attempted. The Rubin Observatory will photograph the entire visible sky every 3 nights, creating a time-lapse of cosmic motion and change across years. It will detect not just interstellar objects, but new asteroids, comets, supernova, and more in real time. Most importantly, it will allow us to catch objects like 3-eye atlas sooner. With more warning, astronomers can prepare coordinated campaigns to observe future visitors with dozens of instruments simultaneously. This means we won't just get brief glimpses. We'll get data-rich portraits, high-resolution spectra, time series photometry, motion tracking, even 3D modeling of interstellar trajectories. In other words, the next time something enters our solar system from deep space, we won't just watch it fly by. We'll study it, measure it, and maybe understand it. But there's another possibility, one that few dare to say out loud. What if we detect something that's clearly unnatural? A geometric shape, a consistent pulse, an energy signature that doesn't fit any known physics. What happens then? Are we ready for that discovery? More importantly, would we even recognize it for what it is? Astronomers like Avi Loeb are calling for protocols. If an object like 3I Atlas displays behavior that suggests propulsion or control, non-gravitational acceleration, for example, we need ways to test that objectively. We need transparency, collaboration, and a willingness to ask questions that once seemed ridiculous. Because today's impossible is often tomorrow's breakthrough. The scientific tools are ready. The eyes of the world are watching. And as objects like 3I Atlas continue to appear, one thing is certain. The more we look up, the more we'll realize we've only just begun to see what's out there. Right now, 3I Atlas is sailing silently through the solar system, a cosmic messenger from an unknown origin. It will pass us only once, and then vanish into the dark forever. But in that brief moment, it offers us something priceless, a chance to ask the questions we're often too afraid to voice. Are we alone? Or have we always been part of something far bigger, far older than we can imagine? 3I Atlas may be just a rock, or it may be a clue. If you enjoyed the video and want to support our work, you can do so by clicking Super Thanks. Thank you so much for watching, and a huge thank you to our channel members for your continued support. And what we find next could change everything. So if you've come this far, stay with me, because what's coming after this will challenge everything you thought you knew about the universe. See you on the next video.